In this lesson, we'll review a math question from the problem solving section. We're on page 852, question 20, the final problem. We know this difficult question. So I've attempted to reproduce this diagram, and you could look in your book. It's drawn a little bit more accurately there. And here's the question. SBT is a quarter circle with center R and radius 6. So here's the center R, and we know the distance obviously from the center to the edge is 6. If the length plus the width of ABCR, so ABCR, we have this rectangle within this quarter circle is 8, then the perimeter of the shaded region is what? So we have to find the shaded region. So let's just start with the easy part of the shaded region. SBT, this outer part, or ST, this is a quarter circle. So if you want to think about it, you could expand it to the whole shape. But we know that this is a fraction of the whole circle. The whole circle around is the perimeter. A proportion of that is an arc. If it's a shaded part, the area, which is the proportion of the area, that's a sector. So let's just figure out the length of this arc. It's a quarter circle. So let's start. Radius is 6. So we know circumference equals 2 pi r. The radius is 6. This whole circumference is 12 pi. But what proportion do we want? We want 1/4 because it's 90. This is 90 out of 360. It's 1/4. So 1/4 of 12 pi is 3 pi. So that's the first part. We know this outer arc is 3 pi. So if you look at the answer choices, we know it has to be 3 pi plus something. So you're already right down to A, B, or C. So let's now focus on this part. Okay, so here and here, let's forget about this diagonal line for now. So here and here, let's think about it. This is a little bit of reasoning, but we know from the center of the circle to the edge is a radius, so that's 6. We know from here to the edge, that's 6. So if we just think about both of these together, we've got 2 radii, that would be 12. And anytime information is given, you want to use it, it'll play a factor in solving the problem. We're told the length plus the width of this rectangle, ABCR, the length plus the width is 8. We don't know individually, but we know this and this together, the sum is 8. So let's think about it. If these two together are 8, we know all of this plus all of this is 12, right? 2 radii. Doesn't matter what each length and width is. They add up to 8. 12 minus 8, we've got plus 4. So hopefully you can gain that. So that plus 4 is going to be this section plus this section. We don't know collectively, but we know it's 4 because it's 12, subtract 8, and we get 4. And the last part is this line. And this looks a little tricky because I think students are trying to figure it out, but you have to just keep looking at it, and it's sort of a reasoning problem, and I'll just show you how to do it. Alright, this is a rectangle. Alright, this is cut in half. It's symmetrical. What if we did this line? Isn't this line the exact same length? It's a rectangle, right? So we know that this diagonal has to be the same as this diagonal. What is the diagonal we just drew? Well, it's from the center R to the edge. That's a radius. That's 6. So plus 4 plus 6, the answer is 3 pi plus 10. So it's a difficult problem. Again, you just have to kind of focus on the information that's given and know your concepts. I think it's manageable if especially you have a little bit extra time. The answer here is B. Alright, see you next time. Thanks for watching.